Let me hand over to Charles for also his first talk and an intro to Redux. Thank you.
Wait, can you guys hear me up back? Cool. So hi, I'm Charles, and you're all very terrifying. I'm also a GA grad, and I'm also part of the team at Thickmill. The reason why I moved to Thickmill was because JavaScript really is interesting and React is awesome, and how cool is ES6? Yeah, so that's me in a nutshell. This is going to be quite brief. It's just going to be like an introduction to Redux and why I think it's cool. I've had the opportunity to work with it on a few projects in the last month or so, so hopefully this isn't entirely useless. Let's continue. Before I sort of start the talk, I want to give a shout out to Lynn Clark, who is an amazing developer and also an amazing illustrator. If you haven't checked out her code cartoon series yet, please do. It explains a lot of really complex and really hard to understand concepts in a very easily digestible and cool manner. And it's helped a lot in preparing for this talk and working with Redux in general. Actually, just before we start again, has anyone actually here worked with Redux before? Hands up. Cool, so it's pretty awesome. Do any of you know what Redux stands for? Shout it out, maybe. Cool. Did you know there was a diet pill called Redux in the 1990s that was recalled? I just thought that was funny because it's like diet Flux. But let's move on. So again, I'm sure most of you know about states and props in React, and there really isn't much to say about this here apart from the very basic idea that states are mutable and props are immutable. Why this is important in terms of Redux and indeed Flux is because unfortunately, as your app progresses and grows and is used, states will mutate, right? They'll suffer from mutation. Why this is relevant is sure. And this is fine if you're working with a relatively small application because it's easy to track mutations, easy to track change. But as your application grows, as there are more models and more views, things become a bit more complex, harder to check, harder to trace, harder to debug, frustrating for everyone, right? A classic example is Facebook's notification system. There was a bug, I think a few iterations ago, where notifications would pop up, you check them, there'd be no messages, you do something else, notifications would appear again, but again, no messages. And this would continue and continue and continue. Not just for users, but also for people who are trying to debug it in Facebook. And it's sort of like a general illustration of why this kind of issue is a problem. This is sort of where unidirectional data flow comes into play, and the creation of Flux as a concept, I suppose. The great thing about this is that it separates your state logic, your data structure, from your views. And everything is predictable and traceable in a easy to understand manner. So nothing really gets to change your states apart from the actions. Actions get called by views. They get dispatched to the store manipulates and mutates your state, and then passes it back to your views. This is all really cool, and because data is extrapolated to this sort of extent, it's taken away from the view, and also it's easy to trace. It makes your app a lot more predictable, and it makes debugging a lot easier. And you don't end up like this situation, awkward twister. So Redux, why is it cool? Why is it good? It expands on the Flux idea. Dan Abramov had a really sort of looked at Flux and thought, there are a few things we can improve here, and a few things we can simplify and change, and create a few other cool tools to play with. Before I get into that, I'd like to talk about pure functions. If people who have worked with functional languages, they should be very familiar with you. People who don't, it's a pretty simple concept. Oh, yeah. Functions that are pure don't depend and do not modify the state of variables outside of its scope. In other words, given the same parameters every time, a function will always return the same result. why this is relevant to Flux is because, relevant to Redux is because Redux uses a lot of pure functions in its components, and I'll get to that shortly. And why this is good is because it means that any sort of problems or data changes are localized within these pure functions, which again makes them easy to trace and predictable. You can see a trend there. Yes? Pardon?
You did test it?
I would believe so, yes. Cool. So the Redux model isn't very different from the Flux model. The main difference is that there really isn't like a set, dispatcher. Dispatchers are typically handled by the store. That's a very minor change. So there's really like three main components in Redux. Your action and creators and actions, your store, and your reducers, right? Your action creators are very similar to traditional Flux, except that they are, again, pure functions. So they don't invoke a dispatch within the function, they just return an object, and that object is your action. If you want to dispatch in Redux, Redux has its own dispatch method, which allows you to pass in the result that gets passed to the store. Actions are typically objects with a type, and apart from the type that specifies what kind of action it is, you can really do whatever you want with that object. It has to be as simple as possible, obviously. If you sort of strip that down and pare it down, it's basically a description of what's going on, what's changed in your application. And that gets passed to your store, like this sort of message here. This is your store. It's much more stripped down than Flux. It doesn't really do as much. It doesn't handle any of your state logic. All it really does is receive your actions, and then once a state has been returned, or a new state has been returned, it passes that to your view. Any sort of logic in terms of manipulating or changing your state is handled by the reducers, and that's sort of a new concept in Redux that isn't really touched on in Flux, but it really isn't that different. This is a reducer. Well, a set of reducers. I'd like to think of the guy in pink as the root reducer, and in a small application, root reducers generally handle all of the logic. They get past actions and also the initial state, and then it does whatever logic it needs to do, at which point it passes a new object with all the state data in it back to the store. The key here is that it's a new object. It's not mutated. It's not a version of the old object. It's an entirely new object. And if you have like a larger application, then you can have multiple reducers, much like these chimpanzees here. They're in charge of slicing up your state and sort of looking through that, looking through your actions, seeing what needs to be changed, changing that, and then returning a slice of that object. In reality, what your reducers are is just really this, right? It's just taking in a state and an action and then passing back a new state. That's just really as simple as it gets. Your root reducer is really, conceptually, it's dot reduce, right? It's just taking a bunch of objects which are slices of state and then flattening them into a new state object or a new single state tree. The cool thing about like Redux and multiple reducers is that they can be hierarchical. So I'm sure most of you know that in Flux, stores are generally flat in structure. They don't really have anything to do with each other, or they generally don't. Reducers are hierarchical.